All right. Um, Hopefully you guys were able to finish your notes as well as work on your classwork for this unit. And and if you have questions, you should have been sending me Schoology messages. So you've taken your Are You Ready quiz, and we're going to go over those answers now. But you can expect to see things like this on your test. The difference is that I did give you some hints about how to do some of these problems. After them in parentheses on each one, you won't have those hints tomorrow on your test. So let's kind of talk a little bit about how these problems work. Okay, so how many grams are in 56.9 moles of magnesium? Okay, so we were given the 59. Let me see if I can make my thingy work. 59, excuse me, 56.9 moles. We're looking for grams. And so we are talking about magnesium. And then down here we have our 75.9 moles. And again, we're looking for grams. So we start with what I underlined, which was 56.9 moles of magnesium and 75.9 moles of magnesium. And then we do our T charts, okay, our T bars. We are then going to look up on the periodic table because we know that if we have 1 mole on the top, we have to have 1 mole on the bottom to cancel it out if we're doing our dimensional analysis right. And we're going to look on the periodic table at magnesium. So if everybody will pull out their periodic table and they'll find magnesium is atomic number 12. And if you look at the bottom of it, it says 24.305. Okay, well, we round everything on the periodic table to 2 numbers after the decimal. So that should now make it 24.31 grams of magnesium. So the moles cancels out, and now I'm left in grams, and this one's 24.31 grams of magnesium. Now there are 3 significant digits in the original number, and then there's 4 off the periodic table. So our answer should be rounded to 3. So when we do this one up here, we actually get 1383.24, but you should round it to just 3. So we'll do 1, 2, 3. We look at this digit, it does not round that up. So it's 1,380 grams of magnesium. That would be our answer. Okay. Now this one over here, when we do it in our calculator, should have been 1845.13. So again, we do 1, 2, 3, but this one does round that one up. So that's 1,850 grams of magnesium. Okay, so got to pay attention to all those things as we do these problems. Our next one, number 2. Now we were looking for liters and we were given moles. Okay, so again, liters and we were given moles. And the key thing about this is on our roadmap, we have moles in the middle. And on the previous one, we had mass. So we went from moles to mass. And if we look at our roadmap, we have moles and then we can also go to volume. Well, volume is our liters value. So that's why I said it was one step on your mole map. Okay. Now, if you look at your periodic table formula chart, it tells you that at STP, which is standard temperature and pressure, that 1 mole is equal to 22.4 liters. That's what you need to know. That's one of the 3 major conversions that you're expected to know for the test. Okay. So if we have 2.89 moles, we're going to start with what we were given, and it's oxygen gas. So I'm going to write that as O2 because it's a diatomic. And then 2.12 moles of oxygen gas. Again, okay. So if moles are on the top, on my next conversion, it has to be on the bottom. All right. And because I'm looking for liters, I know for every 1 mole, what did I write at the top? It's 22.4 liters of O2. And then 1 mole of O2 is 22.4 liters of O2. So again, 3 significant digits needs to be in my answer. So if that's the case, on this top one, we get an answer of 64.7 liters of O2. And then on the bottom one, we should get an answer of 47.5 liters of O2. Okay. Again, it's a one step because we just had one conversion factor that we had to use to cancel out the moles. Moles to moles, then we were automatically from moles to liters, and we're done. So that's just a single step on our mole map. All right, how many molecules are in this many grams? Okay, so again, we're looking for molecules to grams. Now, we can't go straight from grams to molecules. If you look at your mole map, okay, grams are a mass value, molecules are a representative particle. And that's going to be the key thing to remember, is that molecules is a form of a representative particle. We could have asked about atoms. We could have asked about formula units. If it's a molecular compound, it's molecules. If it is an element off the periodic table, the representative particles are atoms. If it is an ionic compound, then the representative particles are formula units. This is all in your notes, and I was there when we did those notes, and so that's something that you need to know as far as something I'm going to ask you about for your multiple choice even. So you need to make sure you know what representative particles go with what thing, okay? But as I was saying, we're going to have to go from grams to a mole and then moles to a representative particle. So that's why I said it was a two-step problem on the actual mole map. Okay, so we're going to start with our 4.56 grams of H2O. Well, in order to get grams to cancel out, we have to find what's called the molar mass of H2O. So we have an H, and we have two of them, and we have an O, and we have one of them. When we look up the mass off the periodic table for hydrogen, and we round it to two numbers after the decimal, it is 1.01. And when we round the oxygen, it becomes 16.00. So we end up with, let me see if I can move this from that. Nope. Okay. So we end up with that value would be 2.02, and this value would be 16. So those two values now get added together, and that is 18.02 grams for every mole. That is known as the molar mass. So we're going to use the molar mass, which is 18.02 here on the bottom, because that molar mass is always what 1 mole of H2O is. Same thing down here. I'd start with my 3.56 grams of H2O, and then I would say that 18.02 grams of H2O is 1 mole of H2O. But I don't want moles. I want my answer to be in molecules. So the thing that I need to remember is that for every 1 mole of H2O, how many representative particles is that? 6.02 times 10 to the 23rd. And that would be molecules, which I'm going to abbreviate as MC on here. So 6.02 times 10 to the 23rd molecules is 1 mole of water. So moles cancels out, grams cancels out, grams cancels out, moles cancels out. I'm now in molecules. So in our calculators, we're going to do our original number that we were given. So 4.56 multiplied by 6.02, second comma 23, divided by 18.02. And then we're going to hit the equals button. Now this one's only supposed to have 3 significant digits. So since it's only supposed to have 3 significant digits, it will end up as 1.02 3.52 times 10 to the 23rd. And that will be molecules of H2O. Then down here, we'll do the same thing. 3.56 multiplied by 6.02, second comma to the 23rd, divided by 18.02 is going to give me an answer of 1.19 times 10 to the 23rd molecules of H2O. Okay. All right. Again, it was a two-step problem because we had to have two conversions. We had to change it from grams to moles and then moles to molecules. So just remember that you can't skip the moles middle part. So if you're not at moles, you have to get to moles before you can go to a different part of the map. All right. Now my next one. What is percent composition of chlorine in AlCl3? And what's the percent? So we're looking for percent composition, and we are given the compound AlCl3. Okay, we are looking specifically for chlorine in this one. All right, same thing down here, but now we're looking for boron, and we're given BF3. Now, the key thing to remember about percent composition is, as I wrote down here, it is the part. So the part would be the chlorine divided by the whole. And all of this is about the molar masses. Okay, so chlorine on the periodic table, I just knocked that over. That's okay. Chlorine is 35.45 when it's rounded. So Cl, and we have 3 of them, is 35.45. And then Al, there's 1 of them, and that is 28.0, 26.96, I believe. Yeah, 26.98. I do know how to read. I do not have my glasses on though. So yeah, 26.98. So now we have to do some math. Okay, so while we're doing our math here, we're going to, so you should have your calculators. And as you're doing your calculation, that will give us our 26.98 for this one. But for our chlorine, it'll be 106.33. Oh, you cannot see my numbers. Let's see if I can do that over here. 106. Jeez Louise. Let me see if I can make it go down a little bit. All right. This would be 106.33, and this one is 26.98. We're then going to add those together. So that's going to give us a total of, so we're going to have our part. Well, our part is our chlorine right here. Our part is our 106.33. Okay, and that's grams. And then our total is all of that added together, which is 133.33 grams. So that would be divided by 133.33 grams. We're then going to need to multiply it by 100 to get it into a percentage. So when we do that, we get 79, and we need to have 4 significant digits because of our original value. But we could have 5 significant digits, but 76. I typically tell you to round these percentages to 2 numbers after the decimal of chlorine. Okay? If you gave me 5 significant digits on that particular problem, I would have been completely okay. So, all right. On this one down here for our boron and fluorine, we have boron, which is 1, and we have fluorine, which is 3. And then for boron, when we look it up, it's 10.81. Fluorine, when we look it up, is 19, rounded properly. So this gives me 10.81. This gives me 57. I then need to add these together, and that gives me a grand total of 67.81 grams. You need to be able to do molar masses. Okay, that's something that you're going to be asked to do in individual problems. So then, since we're trying to just find boron, it's the part, so it's 10.81 divided by the 67.81, which is the whole, and then multiplied by 100. So that gives us a percentage of 15.94% of boron. Okay, so these are the types of problems that you're going to be doing in your workout portion on your test. You'll have about probably 8 or 9 multiple choice questions, and then about probably, I want to say 6, maybe 6 different workout problems. So there'll be single step conversions, there'll be a multi-step conversion, there'll probably be just a molar mass calculation, and there'll be a percent composition question. Um, and so you just need to be aware that those are the types of problems that you're going to be asked about. Okay. All right. Now this last one, I will tell you, this one you're gonna have to, you're using the poem from your notes, but I'm pretty sure on your test that, yeah, in fact, I know you don't have to actually calculate these on your test. This is something that you do need to know the definition of an empirical formula, and you need to be able to recognize the difference between an empirical and a molecular formula. But I do want to kind of go through this with you just to kind of go through the process. And it does say to use the poem, and the poem said to take the percent to mass. And then the poem says take mass to moles. Then it says divide by small. And then it says round or multiply till whole. Now for you guys, I don't think we really did the multiply part. We just primarily did rounding. But when we're doing empirical formulas are the lowest whole number ratio of a formula. Okay, so that would mean that all of these subscripts are in their lowest form. That's what an empirical formula is. Okay, so you just take these percentage signs and change them to grams, first of all. So we have hydrogen, and we were told we have 12.5%, so we just say it's grams. We also have nitrogen, which is 87.5, and we just change the percent to grams. Then we have to go, so we've done that first one. Now we go from mass to moles. So we're going to take 1.01 grams of hydrogen, which I got off the periodic table, is 1 mole of it. Okay. Then I also know that for nitrogen, it is 14.01 grams for every 1 mole. Again, I just got those numbers directly off the periodic table. Okay. So, and these problems were the same on both quizzes, so that's why I only did it once here on the page. So then when we do that, we're going to get 12.4 moles of hydrogen up here. And then when we do 87.5 divided by 14.01, we're going to get 6.25 moles of nitrogen. Okay, so now we've changed everything to moles. So now we divide by the small. What that means is we look at these two numbers of moles that we just got, and we divide by the smallest amount. So we 12.4 and 6.25. Which one's smaller? The 6.25. So I'm going to divide both of them by 6.25. No, it's not 6.65. Okay, 6.25, and divide this by 6.25, which then tells me that this one is roughly 1.98. So that gets rounded until and this one's 1. So we've divided by the small, and then it says round till whole. So this one right here gets rounded to 2. So we have H2 and N. That's my empirical formula. So that's my answer to the A per question of H2N. Okay. Now, if the molecular mass is this amount, then what I need to do is I first need to find just the molar mass of this. So 2 So hydrogens, I have 2. And I know hydrogen, looking it up on the periodic table, is 1.01. Nitrogen, I have 1, and it's 14.01. So then I have 2.02 and 14.01 is actually 16.03 grams. Okay, so then I'm going to take my 32 grams and divide it by 16.03 grams to find out what number I need to multiply my subscripts by. That roughly is 2, which means that I'm going to take my formula up here and I'm going to multiply the subscripts by 2. So that means that this will be H4N2. Now, if I wanted to have written it as N2H4 and also have written it NH2 up here, I could have. Those would have been the same thing. Okay? So these are roughly the same thing. This is the empirical. This up here is the empirical because of the fact that it is the lowest ratio of those subscripts. Down here, these are multiples. I can divide both of them by 2, so that makes it a molecular formula. That's what you're going to have to be able to do on your test, is be able to recognize what is an actual empirical formula versus what's a molecular formula. Could it be reduced? Okay. That's the way to know if it's empirical, is can it be reduced? If you say no, then it's an empirical formula. If it can be reduced, then it's a molecular formula. All right. If you have questions, please send me a message on Schoology. I'll be happy to work with you on that. Also, work on your review, and those answers will be posted as well.